The Sporland division of Parker Hannifin Corporation is sponsoring this podcast. Sporland is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporland maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max Press to Connect, and Zoom Lock Push to Connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporland.com.
I guess that's Jim and John for Sporland signing off.
This episode is sponsored by United Refrigeration and Westermeyer Industries, revolutionizing your HVACR experience. Visit URI.com for all your HVACR needs, offering real-time inventory, personalized pricing, and a nearby stock feature. Access quick pick replacement parts and branch details effortlessly. With 350 plus fully stocked locations across North America, our knowledgeable staff are ready to assist with the solutions you need. Exclusive offer. Use code ARPOD on URI.com to get a $10 gift card when purchasing the Westermeyer Oil Float, part number W4300-38F. These high-performance floats are not just compatible with their own oil separators, but also available as a crossover model. Conveniently stocked at United Refrigeration. That's code ARPOD to claim your $10 gift card. Visit URI.com now.
The unit information, we could bring it up.
Yeah, I do. I just gotta find it. But yeah, no, we can do that. What is it? Yeah, good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. Sorry, we were BSing and we're like, wait a minute, we should just talk about that. So go ahead, talk about what you were talking about, and we'll get into it while I'm Jamieing over here.
So we're doing one of those pump skid conversions, and we're having issues maintaining leaving glycol temp. We're not hitting set point. And we had some issues with the piping in the beginning. Like, it was very unclear, and the fitters only piped half the heat exchanger, and they went back and repiped the other half, and we're still not getting discharge temps out of it, but we're hitting superheat. But we're hitting superheat very inconsistently. It's hunting pretty bad. We're running no EPRs. We have fixed steps on the rack. So old school Novar, like RC ones. It's fairly stable for now. There's a lot of load coming off of it. It's fairly stable, but like we're just not hitting temps. I think we have too much flow, to be honest to you.
You weren't there though, were you?
I wasn't there today, so my other startup guy was there. But I think we have too much flow. I think we're moving too much through the heat exchanger, and we're not properly feeding it. But then again, if we had too much flow, I would think the superheat would be a little bit higher because we'd be putting a little bit more load on it. But I haven't really looked too much farther into it, but it doesn't seem right. Like I was reading their stuff, and their approach temps are like extremely high for plate and frame heat exchangers, or brazed plate heat heat exchangers, because somebody will come unglued about that.
What I was gonna say is, I know they actually go off the liquid point, I think, when they were doing it. You know how like we typically say, okay, I gotta check, I'm looking for the documents right now, but you know how normally we usually go for pressure control and saturated suction control. As far as pressure control on the rack, we usually do midpoint, right? Because then it's not, the distributor tubes aren't getting too cold, they're not getting too warm. It's just, we have that mix of that.
See, so this would be more concerning if it wasn't 404.
Yeah, which only has a stupid thing of one, right? Yeah. It's not.
It's the last good gas.
I'm still looking, so you're gonna have to bide some time here.
Well, I mean, yeah, it's even with 404 though, it's like a stupid high approach temp, which like most raised plate heat exchangers, you see the approach temps like way lower, like 2-3 degrees, maybe 4 degrees. I think there's 7 plus. It seems high to me, but it doesn't seem like we're effectively feeding the heat exchanger.
do they have the bypass at the end there?
So they do have the bypass in the end, and I had it originally cranked up to 50%, which is way too high. So for us to just to get going and fill a loop, and before we turn out one lineup, or I'm sorry, there's 3 circuits. It's 7 12-foot cases, and we turn that on, and I reduced it back down to a quarter open. So I haven't set the flow yet, but I think it's pointless until we have the entire load. So I'm back down to a quarter open. We're hitting delta P, and the pumps are like 80% running, which just seems high to me for the little bit of load we have.
You got to remember those actually have it programmed where it's doing the oh my god, what the hell do they call it?
Calc for you.
Yeah. Yes, so the pressure transducers obviously have to be accurate, right? That's the first thing. The second thing is, because I had the same issue, and that's where I was talking about, where I was like, I drove the pump down and down and down. I got to a point where it was maintaining even better, and then it went to the point where it was just flooding out. So I was like, all right, then that's what I said. I asked the cats, because they have that new valve at the end where it's like a handle with looks like a big open piece of pipe with the 2 Pete's plugs, but they coincidentally didn't have that, so they put an STAD on there, and that's when I figured out it was too far open. And then I was like, oh, okay, let's just close this down. So when we closed it down, it got way better. The pumps throttled down and then started actually achieving temperature.
Because you made that delta P. Like I think ours, but a quarter open, like with the little bit of flow we have, it doesn't seem like a lot. But I guess maybe it needs to be like a 1/16 of an inch open.
Yeah, they're supposed to come out there, and from my understanding, they're supposed to fully commission it after everything's squared away. I cannot find, for the life of me, I can only find the CO2 portion of that. I'm still looking.
Yeah, I don't fully get it. It's obviously it Pete's plugs up there, and you could set it that way. Honestly, I think we're moving too much glycol, and I thought about moving the delta P down to 15 for the time being, just to reduce the pumps and slow the flow down, because we have preset circuit setters in every single case.
Yeah.
And also, we just got like absolutely fist by every case manufacturer.
I haven't said this in a while, but I hate you. You're just making me go back, but that's fine. That's cool.
So every case so far has come out not wired. Like the solenoids are just curled up inside the case, not wired at all.
Sweet. And it needs to be wired.
And all these blue gel caps that they aren't stripping the wires on, that I want to just curb stomp somebody for, that like they're halfway crimped. It's super awesome trying to figure out why you got 63 volts at the lights, or 60, or the fans are just like going wow, 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 wow. Because
our friend Dylan just actually was talking about that, how just awesome that was.
Yeah. Or you get like Wagos. Like they switched it up on some of them. They put some Wagos there and didn't strip the wires because they thought the Wagos were like the blue ones, and they just pierced the wires for you. And you're like, what the hell is this?
So if I finally found what we were looking for. So the Glycol skid is standalone pipe plus 15 suction SST. My other question is, because sometimes this gets overlooked, but if on these racks, if you don't have a constant suction pressure, now was that something you were able to scope out? Were they able to tell you that it's a constant suction? Because obviously the valve's going to hunt like a bastard if your suction's all over the place, right?
It wasn't horrible. Like it.
Okay, but that
listen,
wasn't horrible. But
28-year-old controller. It's fair to middling. It's in the middle.
No, I understand that, but you can have where over the years someone switched something where now the normally open solenoid is normally closed for the unloader, and now it's eating a whole bunch of shit. I've had a digital one on the Siemens controller. Never have a comm ran in 11 years of the rack being up and running, and the guy was out there with me, Shank, and I was like, oh, look, it doesn't have a comm. He's like, wow, this rack's running a lot better. I was the one who started this up, and I was surprised. I didn't think we'd ever.
His name is Shank. They're the most Texas name ever, like Shank. Holy shit. Is that like a nickname, or is that some
name? It's his nickname.
Did he stab some people?
No, he's not like one of those sling blades. No.
Holy shit. Get a name like Shank.
He has a teardrop tattoo. He's bald.
No, that makes sense. No, like the rack is like fairly stable for like how old it is and what it is. It's fairly stable.
That's going to affect it, right? And
Well, yeah, but like you can't just slap a brand new skid on a 20-year-old rack and expect it to be perfect with no like capacity control. Like it is what it is.
There's no unloaders on the rack at all.
There's 2 compressors with unloaders. They're unloading. At the time, they were running constant. Like it was every compressor was pretty much running.
I got you.
And the head's plenty high because the condenser's.
So this is what. So anyway, so this is what I was getting at. So this says right here. Now this would be with a very constant superheat pipe to a plus 15. Which it depends on how far it is. Like I've seen some where the rack is down on the floor and the pump skid's up on the roof. And yeah, we'd have to drop the suction a little bit in order to maintain the 15-degree out of the actual pump skid. But it says with that, we should be able to run down to 20 degrees.
I'm 15 feet away.
So there should be no reason why it's not maintaining, right?
Like it's literally 15 feet away.
So at the end of loop connection between the fluid return supply, after all the fixtures have been supplied fluid, mechanical balancing valve should be set. So you might have to just get in there and just adjust that down, just start closing it down to maintain flow. That would be my advice.
It's like a quarter open, like right now. I think
that seems too far.
You think so?
Yeah, because you don't even have all the cases hooked up yet.
Yeah, I was questioning it. The problem is I don't really have much. Now we have more because they brought on 2 more lineups, and tomorrow they're bringing on 2 more lineups. So I should have a decent amount of flow. I'm gonna have them tomorrow morning. I'm gonna have the other startup guy just crank that thing almost closed.
Yeah,
and see what it does. But I don't know. Like the TD seems really high.
Only 5 degrees? That seems pretty solid. If you look at the old,
yeah, but we're not getting anywhere near that.
No, I know that. But that's what I'm saying. If you're not moving the proper amount of flow because you're bypassing too much, you're basically just bypassing all that flow directly, not where it needs to go. You know what I mean?
Yeah, no, that makes sense. That's what I was saying this morning. I'm like, I think we got way too much flow.
And knowing in the schematics as well, your guy probably already did it already. There's supposed to be CTs on the compressors, the current sensing relays, CSRs. Sorry, so CSRs, and basically that shows as the proof for the enable for the pump skid. Because when we first got our first one, it was swippy swapped, so there was no. The guy didn't run the lines, but even it should have been enabled the way it sat. So we had to basically flip the enable in order to get it to actually run. Like it usually uses those.
I didn't have to do that. Like I started it up. Like there was no enable. Like there was the only enable sequence was if the rack was below a 30 SST and there was a call for a pump to run, then it was enabled.
Okay. So having multiple redundant sensors, freeze protection. Yeah. So if the flow gets down to 13 degrees, and it wasn't getting down to 13 degrees, and that's usually what it is, where it actually shuts it off. It has like a freeze protection, so it should disable. That should be in the logic of the Corel controller.
Correct. I'm still trying to figure out how to get on those with the laptop. I started to look at it, and
yeah. So here, supply fluid temperature above 21. Disable at 19. Return flow temperature above 22. Disable at 22. Pump supply transducer 10 pounds higher than the return for 1 minute. So lead liquid line enables for these follow reasons.
We have no liquid line solenoids.
Really?
Just EEVs.
You should.
Nope.
Unless they changed it. Now this is I think when it first came out. Because I think they were talking about doing that, and I didn't really like that because if God forbid, let's just say, the power outage, but still, if the EEV essentially is just running and chugging away, and it's just because of a bad sensor, and then it brings that temperature of that glycol all the way down to the floor, it should be able to enable it off, so we don't freeze anything up. So they said something about they were potentially getting rid of that, and that was part of my concern when they said that. I'm like, wait, I don't know if I do that.
Yeah, but nothing to stop it now.
100%. If the control, the EEVs are fallible, right? We all know that. The bipolar steppers, no matter what manufacturer, if it's run horribly, like if it's not tuned properly, it'll wear itself out. And you've seen brand new valves just shit the bed. When they said that, I'm like, I don't know if I would do that. I'd keep that solenoid in there for a multitude of reasons. Because here's the other thing. Yes, if you don't have the proof that the compressor's downstairs and it goes to shut it off, great. But if the EEVs are not shutting off 100%, bad. And you're going to shoot that rack to death.
You're going to have boat anchor Carlisles that are just getting murdered.
Yeah. Plus, that's the other thing that I really, really disliked about what they did. So if you notice, there's no heat exchangers. And I know you like that because you've come and play where on the low temp shit from running so cold, if there's high moisture content within the rack, those heat exchangers create like a Venturi and they'll actually freeze up, causing a pressure drop across it, screwing that up. I get it.
They need them on glycol.
Yes, because they run the superheat. What's the superheat setting? I think it's like
10.
It's 8 to 10. So if you have 8 to 10 there and you're only 15 feet away, that means you're getting 8 to 10 back at your rack, back at your accumulator. Your
hose. But I will say this though, like I have not had good luck with the larger like 2 1/8 to 7/8 liquid heat exchangers. Like they crack all the time.
Really?
So like externally leaking, like they externally crack or rot out. I don't know how many of the Hill Phoenix racks have had to cut those things out. Like the 3 1/8 to like 1.5 inch, that sucks so much
because they sweat so much. You're talking.
Yes, because they sweat so much and they're steel and they literally rot out. No matter how
where the steel meets the copper, right?
Yep.
That yes. I've even seen that happen on like some of the bullseye stuff where you have the remote header and they have that for sometimes they don't get enough subcooling because they're having to run up and over, so they put those in there to give you a little bit more subcooling and protect from lower superheat coming back. So you'll have that in there.
They do work, but like the problem is you're robbing Peter to pay Paul, but like you have a lot to rob from Peter because your superheat's so low, especially on Paul. But they're not reliable. If they were brass, it'd be awesome.
If they're just all one solid piece of brass.
Yeah, or because there's no way, I don't care how good you insulate that, you're never going to keep it from sweating.
So this is funny. The following alarms can be toggled. So you saw how it was 15 degree. Oh no, they're just trying to maintain 20 degree glycol temp. Never mind. I'm like, wait a minute. Never mind. That's dumb. I was being stupid. End of line less than 2. End of line delta less than 2 psi D for more than 5 minutes. Basically pump failure. Okay, that makes sense. But that's what I mean. Like all these different failures that would essentially cause the shit to like stop running. That's why I don't like the fact that they removing that liquid line solenoid. See, on the other ones they had the liquid line solenoid. And you saw, I don't know if you were physically there, but like those XHEXD controllers, they show valve percentage and superheat when they're enabled.
Yep.
And when they're not enabled, it'll just show a pressure. And then I forget the other thing that it shows, but I do know when it just shows straight pressure, it's basically not enabled.
Yeah, it's a little bit of a learning curve on those. They're a pain that they haven't set up in the controller, at least where you could read them, but they definitely need tuned. Like 100%. The PID that's in there is all over the place.
Yeah.
And I agree. I think they need to look at line solenoids there. And I also think they need an EPR.
Okay, yeah. So the other glycols that we're used to, right? The older Hills, right? They had the digital unloading, at least on one of the compressors, on one of the Bitzers typically, right? Yep. If you had that or a VFD compressor where you could actually maintain that steady, I agree with you 100%. Because that's the problem, right? If your suction's jumping around so much, the expansion valve's, okay, 5 degrees of superheat. No, shit, 8 degrees of superheat. Like it can't pinpoint exactly. It can't pinpoint what the hell it's at.
It's the same problem with all the CO2 racks. Like you can't expect to get peak efficiency out of a valve and a controller when you're moving the variable all over the place.
100%.
It's like that almost got you $1, dude, on with the dollar hanging out in the fishing pole. Like it's the same thing. Like it's smooth. You're just constantly moving the target.
This is that valve you're talking about where you have it little itty bitty past, little bit open.
Yeah.
Oh my! Can you not see?
I can't see.
Yeah, I know. Jamie's because I didn't do entire window because I don't like seeing it. Like everyone see like how horrible my desktop is. This valve right here. Yes.
Yeah, except ours is massive.
Yes. Yeah, this makes it look like it's really not that big, but it's freaking huge.
Yeah, ours is 2-inch.
Yeah. No, but like I said, I like when I was there, they unfortunately they put in the STAD. So this right here, look, 2-inch. You said yours is 2-inch.
Yep.
So the range is from 0.5 to 5 PSID.
Holy shit.
That's what I'm saying.
Yeah, I'm gonna close that down way.
Just a little bit.
Yeah, just I'm gonna make him close it all the way and just crack it and see how it does.
That's it. That's. I had that STAD just to give you a little bit of reference. I only had it open to 0.07. You know what I mean? So because it usually goes from 0 to 5, right?
Yeah, I'm gonna have him just crack it. And unfortunately, I have the Pete Sports in my van, so he doesn't have the Pete Sport plug kit. So we should have it like at least half a load onto it tomorrow. After they start these cases, after we rewire all the cases for 4 hours and figure all that out. And the KE2 case controllers have been a absolute learning curve treat. Also, they got thrown into this. Getting them online is a pain.
So do they have just a regular blank board, or they have the board that has like the blue on it?
It's the blue.
So it looks like the RE2?
So it looks like the RE2. It looks like they took us. It's that. It is that. Okay.
That's what the RE2 is. That's what I
was. With a Sporlan display. If you took the newer Sporlan case displays, and took off Sporlan and put KE2 there, that's what you got.
Once again, I hate you again, but here.
What?
This one right here?
Yes.
Then that's the RE2. I don't understand why we can't use the RE2 manual. You know what I mean?
So it's different, though.
Okay. Because that's why I was asking, because I know they have something like this, but it doesn't have the actual blue on there.
Yeah, it looks smaller than that, but like it's what's super frustrating, like we found is like the OEM programmed most of these already and changed the password on all of them. So you have to go through and you have to change all the passwords, which is a pain in the ass because it is a 35-letter like password to change it back to. Because why do we need all these capital letters and dashes and everything else? Like nobody's hacking into your cases. Can we just make it like user and pass?
Maybe they are.
So we had to get that up and going. And once we got that, the BACnet addressing is a pain. So like me and Brett talked about at one point, the BACnet instance IDs. So everything with BACnet, like the wording. So if it's CS, and then if a circuit is CS08A, so it'd be 14008 and then 1 for A. So the way they set it up, so there's a naming sheet in there. Then this all goes off of Novar. So you have a Novar like naming sheet. Okay, so 14 is CS for the beginning of the rack. So that's the rack. It's rack C, and then I don't know what the hell the S stands for. Like super, I don't know, but it's CS. So you have to match what is in the network navigation screen of Novar. So if it's CS008A, so you got to make it CS008A. So it's 14008 and then 1. So that's your BACnet address. And then there's actually an address in there. So if it's 56, you put 56 in the above it. And then it has the wording for the description has to be exactly how it is in Novar. If it's CS008 MD meet, all capitals, it has to be exactly like that. It will not come online.
So the cat was there from Novar actually doing the programming? Or you were on the phone with someone?
No, I had to figure this all on my own.
What? What?
Yeah, like nobody from Novar is there. Nobody from any of the OEMs are there. So there's a ES1 there that I had to find because our electricians didn't say anything where it was and it was hidden. And I finally found the ES1 and just fumbled my way through messing with the BACnet stuff from learning it on the E3 because I've done so much of the CC200 stuff on the E3. I'm like, okay, this is how you get this number. Like I figured that all out the one day, just fumbling through it. So I had to figure out how to get this comm all set up by myself.
How did you get into the ES1 to fiddle screw around?
two ways. So you could see it from the screen. If you go into network navigation, you can see like where it lists all your comm stuff. So you got it'll be rack controller, it'll be comm, like what comm it goes to, and then it'll say 14.00081. Okay, so that's CS0081, or that's 14.001, which would be CS008A. That's what the case ID is.
Okay, so you didn't change anything in the ES1. You changed it on the KE2.
I had to change it on the KE2.
Gotcha. Because I was confused. Because I was like, how did you change stuff in the ES1? Because usually you have to have their special super secret software that they don't let anyone have.
You don't need a software for ES1. It's all web based.
No, but you need like all the secret stuff to get in because the guys
and username. That's it.
Oh, okay.
So I have the guest password to get in. So I was able to hook my laptop up to it and see all the stuff. And then I was able to force a scan and pull everything up. Now, otherwise you had to power cycle the ES1. Now, the other thing we found in all these cases is the manufacturers are only running one comm line down. They're supposed to have a comm line in and a comm line out. So it's a daisy chain. It's a BACnet daisy chain. So they're all only running one comm line down to the controllers.
So what, it goes from the rack to the pump skid out to the controllers?
Nope. It goes from the controller. It goes from the controllers, the typical Walmart, new Walmart. So you got one controller just for the cases.
Yes. The blue and gray box.
Yep. So it's just pulling for the cases. So you're going into case A, like whatever circuit's the first one, and then going to case B, then case C, then the next lineup. The problem is the first two manufacturers we did only pulled one line because everything's top fed. They only pulled one comm line down to the controllers.
Oh,
so it's a star.
Oh no!
Every single case controller is a star because the EMS electricians are like per the print are only supposed to land on the top terminals of the case, and that's it. But there's not an in and an out. There's only an in. And I guarantee you there's a bunch more stores like this. So the case manufacturer should have brought two RS-45 wires down to that and back up.
Oh, because there's only one Ethernet on this guy.
They're not pulling Ethernet. They're pulling RS-45. So the problem with the Ethernet on those, this is the next thing I want to bring up. The problem with the Ethernet on those, which Dylan touched on it. So if you have a lineup of cases, say you have 3 cases in a lineup. All right. Your RS-45 into all of them. But that's not how it was designed to work. So there should be a router, and those 3 cases should be tied from Ethernet to the router. And then you go into the KE2 and go into bonding and find them all and bond them. Otherwise, unless they have scheduled defrost, they will not go into defrost at the same time.
Oh, shit.
You have to schedule the defrost. You have to set the defrost in these cases as you're doing them because they all start up as midnight.
Today's episode is sponsored by the RefRush RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
So they will all, if you go through and do them and you don't stagger the defrost schedule as you're doing these cases, they're all going to be midnight. Or they're going to be demand defrost, which we had no coil temp sensors.
That's what someone else was telling me, that some of the cases, like the me case and stuff, were going on demand defrost. So it was just turning them off randomly, probably because they didn't have them bonded together.
Correct. They don't have them bonded together and they're turning off randomly. But the problem is nobody supplied routers in these jobs. and there's no notes about the Ethernet cabling. There's one note on a walk-in one, but nothing about the cases. So
you can't bond them together via the 485.
Only Ethernet. From what I've read in the manual and what I've looked at, you could only bond them to Ethernet.
So basically, what it should actually be is if you have one set of meat cases, right? Theoretically, what I'm gathering here is that you have the 45 landed right on the controller, and then if you have meat case 1B1, 1B2, 1B3, all three of those need to be Ethernetted together.
Correct.
And then that'll bond them all together. But that wasn't the way it was written on the print, is what I'm getting.
That's not the way the print shows it. The print shows each case getting picked up by RS-45 and no Ethernet lines.
That seems silly.
There's a note in there where it says that like cases may need bonded, but there's no routers.
You look at that.
Who's going to supply 40 plus routers, and where are we getting power for the routers?
Why would you need the routers again? Because if you're basically,
you can't bond the cases together to go into defrost at the same time. So like they could still come out of defrost at different times.
So if you Ethernet them all together, it won't wait until all three of them have defrosted.
Unless they're Ethernetted together, they won't come out of defrost and go into defrost at the same time.
That's what I'm saying. You wouldn't need the routers if you would just 45 all the way around for the loop just for the primary cases, right?
Yep.
And then CAN bus them together with the Ethernet is what I'm
gathering. From what I gather, I haven't talked to KE2 about that, but from what I gather, that's how it should be. That was the design intent with it.
You know who we need to get on here?
Who?
Ed.
Curran? Is this his baby now?
I don't know if it's his baby. I'm just saying, like,
they own them now.
I don't know who owns them, but
Novar owns them.
Really?
Yeah. So when you call KE2's tech support, it's that same Novar like thing that just infuriates you, like that message.
Gotcha.
Yeah. So they're owned by Honeywell now.
Nice.
But yeah, other than that, like I will say this. Absolutely don't use your phone to try to do these.
He warned you.
It's because you go to switch like pages and it locks up and then it kicks you off and then you have to sit there and wait because it won't let you log on more than one mobile device on there. It's what it keeps popping up. It's so much better on a laptop. I haven't tried it on an iPad, but like a laptop is actually functional.
And
then other than that, like going through everything and making sure they're set up for deleting the coil temp sensor, because we don't have coil temp sensors on any of these, making sure they're set up for solenoid. I had a bunch of these that were set up for EEPRs, a bunch of them that were set up for stepper valves.
And what they do if there's glycol, it's just solenoid then, right?
It's solenoid, so you got to set up as thermostat. But like the refrigerant type, you still have to pick a refrigerant type. There's no glycol. Like you still have to pick like R404.
Really?
Yeah, because there's no glycol setting in there.
Sweet.
This is what I was talking about.
This right here?
Yep, right there.
Yeah, that's why I brought it up. I figured because you were talking numbers and it gets confusing when we're just rambling about shit. So rack name. So if it's what rack was it? Rack 2?
It was rack
CS. So it'd be 3, right? And then that would be the circuit number.
Look down. Right here. No, look down. CS is 14.
Oh, shit. I didn't see that. Okay, sorry. CS right there. So it'd be 14. And then, okay, so 14. And then if it was case 1, it'd be 001. So they have 004 in this instance. So that they're calling it like case 5, right? And then, yeah.
That'd be circuit number. So the 004 would be circuit number.
Okay, and then
rack, circuit number, and then case ID.
So case ID would just be 1. So what happens if you have it then CAN bust over then? Does it?
I would think it would carry the BACnet instances. I don't know if it would work for COM. I haven't asked that question, but it should. If they're all bonded and sharing, you would think that the lead case would do the data processing. That's what SC3 does. That's what CC200 does. That lead case does all the data processing and pass through.
Yeah. But so you see how they're identifying 13 and then A, B, C, D, E, right? Okay, so that'd be circuit name. So that's what they are going to do, 1, 2, 3, and then you could bond these 3 together. Yeah. Because it still needs an identification for that thing to go into defrost, unless I'm just talking out my ass, which could be.
Okay, this is good. All right. So when you look at the ES1, this is under network navigation.
Mm-hmm.
So you go in there, and then this is how it's broken down. So you got device, you got the status, whether it's down.
Mm-hmm.
Most of the time it says down.
Mm-hmm.
And then to the right, you have these numbers, random numbers, okay? So the first number is what EMS it is. So that this is controller 3.
Mm-hmm.
All right? And the next number is what COM port it is. So this is COM port 2.
This guy right here.
Yep.
Mm-hmm.
Okay. And then the last number is your BACnet address.
Which is your 131.
Yes.
Okay.
Now, these have BACnet addresses and BACnet instance IDs. They're different. So the instant ID is how it's written out. And if they both are not in there, they will not communicate. Some controllers don't use BACnet addresses. They use instance IDs in some things. Some have both. This has both.
So this has the BACnet address here.
And it also has the instance ID. So if you look down, go down. So see how that's B01. It shouldn't say B. Like, this is the EPR. But if it was, it would say CS01A. Okay, so that would be equal to 14.00011. That would be your BACnet. The way it's spelled out is your instance ID.
Let's go down some. BACnet addressing. So that's your BACnet ID. There's your range. BACnet address. And that would be, oh yeah, because there was another document that I was looking at. Hold on. Where it's basically showing the ranges of, so here's your ketotherm ranges from like 400 to 599, right? So those are like what they have for those. So that would say that number for BACnet is going to be, yeah, right?
Yeah.
So it'd be the 400 would start here then essentially. So it'd be, 401, 402 for anything ketotherm, right? No, it's not.
So like I had stuff that was address 69, address 71.
Interesting. That's interesting because this document, unless, like I said, this document is when they first came out, but case, right? So if it's a Sporland Parker, blah, Emerson, Therm, 400 to 599.
Where'd you get that?
I don't know. I think I stabbed a man or something. I don't remember.
You have to send that to me. But yeah, so like that's what we found. And then go back to that screen when you had the where you had the Novar stuff up.
Yes, sir.
I want to bring this up because this came up the CC200s. So go down, or I think it's okay right there. Okay, so see where it says, where is it at? I just seen it. So Max Masters. Okay, default is 127. If that isn't set high enough to the number of case controllers you have, you can only bring on so many case controllers. So I had an E3 where it was set at, the Max Masters was set to 10. Max Masters was set to 10. Okay, so we had 20 case controllers. It would only bring on the first 10.
Oh, it wouldn't read the rest of them. So
it wouldn't read the rest of them. So we had to end up, you have to take that and make sure that's set to higher than how many case controllers you have, or else you're never going to be able to bring all the case controllers in.
Unless it's done like this, because look at this. So you have the range here, 0 to 127, and then you can see anything 128 on to 255 would be your slaves. So I'm wondering if that's how they coordinate it. You have 127 primary, up to 127 primary, and then slaves would be any of these numbers accordingly.
So you would think then the slaves would be like the B case and C case.
That's where I was getting at. You'd have, it wouldn't go in a succinct order, but you could have 127 for like your primary one, and then like 128 and 129 for your other one. But then that would throw off they wouldn't go in a line. You know what I mean? For your master and slave, right?
They don't on the SC3s. If you look at them, like your master's 7, okay, and then every one after that is like a ridiculously high number.
Okay, so then they're doing the similar thing, right? Where you have the range is of the primary controller from 0, like in this instance, 0 to 27. So let's just say, and they probably knock it up to 0 to 127 in case for future expansion, right?
Correct. I think it's a generalized thing from what I've seen.
Yeah. So 0 to 127 would be, okay, we have the capability to have 127 primary controllers, and then we have the availability to do this many slaves. You know what I mean?
No, that makes complete sense. The more I'm having to learn a lot more of this BACnet stuff than I cared to it at this point, but it's making a lot more sense, and I'm getting more into it. Like it seems easier.
Mhm.
It just takes more time to like actually identify all this stuff, but it all crosses over the HVAC world too. This is what they've been doing for years.
It's not
So
new.
no,
It's not new.
we're behind it, but it seems easier, like how they discover points and stuff, and using like Yabe and stuff like that to do like BACnet Explorer and stuff. Like it's awesome. But okay, so make sure you do the commissioning test when you're done setting up the case controller scroll.
Okay.
So right there, so you got the commissioning test. So
Mhm.
automatic commissioning test, it's going to go through, it's going to set your fan currents, it's going to test the lights, it's going to go through and do everything and test the case controller. I will say this. So none of the liquid line solenoids have been landed when I went to go do these. So what I did, they're all curled up in the bottom of the case for the glycol solenoids.
You don't need
Yeah. So what I did was I jumpered power off the lights, okay, because it's 120 volts coming in. Now, I check this because the KE2s, contrary to everybody else, they're Form C contacts. But the common is on the right-hand side of the controller where everybody else's would be normally closed. So on the lighting contact and the fan contact and the refrigeration contact. So what you have to do is make sure you wire from the common of the lights. You want to take that and jumper over to the common of the refrigeration.
Mm-hmm.
And you want to make sure that you only have one line coming in the case because you want to make sure that the lights don't cycle off on some other contactor. And that way you could power the liquid line solenoid or the glycol solenoid, whatever you want to call it. You power that glycol solenoid from that light contact, but you want to unplug the lights to make sure the glycol solenoid still functions.
Yeah.
Because you don't want on a couple of them, the OEMs mixed up the wires for the lights. And when I went to go unplug the lights, it dropped the glycol solenoid out. So you want to avoid doing that. You want to test it. Are you ripping the whole case controller apart?
Maybe.
I just seen stuff flying. I'm like, Jesus.
So I was looking at your relays that you were speaking of. So if anyone could see, actually, I gotta do one of these numbers. Stop screen for 1 second, just so I can see it. This way. So there's your relay, right? Yep. And there's one fuse right there, and then left ready. And there's another fuse over yonder, and there should be your display. I'm trying. I was trying to see what you were talking about, like as you're talking. Oh, the comms on the right hand side.
Yeah.
That's silly, and you won't really actually see that. I mean,
because it's up in the case, and you can't even see it.
But you can see it on the front.
Barely.
You can see it on the front.
Not in these Kaiser cases. You can't.
You see on the front.
You can't.
Because
they're up on a tray on an angle, so
I get it.
Like it was not fun, but it's. That's one thing to watch out for when you're doing these is making sure that like you actually get it on the common.
Yeah, because usually the common's right in the damn center. I wouldn't have thought anything different if I wouldn't have actually just ripped this apart just now.
All three big OEMs for EMS common Form C contacts are all common center.
Are all the IP addresses exactly the same? The 10.10.106.240?
So no.
Okay.
But I think the OEM changed them.
Okay.
So I think the OEM changed them when they were in there because I think they come out as that from the stock, and you have to change them if you're bonding them.
Yeah. So I'm looking at this right now, and I'm seeing what Dylan was talking about, because on the other, when he was talking about the pump liquid stuff, like he was like, oh yeah, it doesn't have the whatchamacallit, it doesn't have a solid state relay. These are all relays.
Correct. Yeah, there's no solid state relays. It's just we're just turning off glycol solenoids. So you guys got to make sure. I think it's like a 2 or 3 degree deadband and whatever the temp is for the case. But make sure your defrost is right, because I had a bunch of cases come out where they were programmed for a 30-minute defrost for these meat cases, and spec for the case is 45.
You know what? Since K2's not, Ketotherm's not coming on here wanting to talk to us, I think that we bite the bullet. I got an E3 here, I got an E2 here, and we just hook the damn thing up. We run it in comm, and we get it to communicate. We should have talked to our buddy about getting a
license.
license.
We're trying to educate people here, guys. We need a license for the E2 so we can communicate to this right here.
We can get that with a CC200 that Brent never sent me.
Yeah, what's up with that?
I don't know. I have one here, but I need a display.
So they sent someone sent me a display, but it was the wrong display. It was actually like a case controller for something just totally rogue and random.
Yeah, I'm gonna try to have him mess with that in the morning. I'm gonna have him try to mess with that flow and see if we can get it to calm down a little bit. It definitely needs tweaked and tuned, but at the same time, like when we were looking at the prints, we only piped half the heat exchanger because on the print it only shows one suction line going out and one liquid line going out.
Really?
Yeah. So if you look at this, and I look at this for 2 hours going through it because it's very unclear. And there's a note at the bottom that says tie
on this or on the piping
on the actual piping.
Okay.
There's on the actual like customer print. There's a note on there that says tie liquids together as a common liquid and tie suction lines to rack. That's all it says. There's only a schedule where it shows one suction line tie-in, but it has two. So you need two individual suction lines going. But in our case, it wouldn't have worked out anyway because there wasn't room to get into the rack with 2 2.125 lines. So we had to demo out the meat lines to bring the second 2.125 line in. Nor could you fit 2 2.125 tie-ins on the header. There's just no room.
So this is what I was talking about. Oh, wait. No, that's awesome. Didn't go. Share screen. Yeah, we just need to get these people on here. I keep saying that we're going to get them on. We're going to get them on. They just keep avoiding me. Just don't want to talk to me. Anyway, so you have, this is what I was talking about before, where you have a current switch, and that's essentially your enable, right? So if not at least one of those compressors is on, because of the way it's wired, they're all wired in parallel. So if you don't have at least one compressor going on, it should disable the whole kit and caboodle.
We're on the old school EnviroGuard lockout.
Essentially.
Yeah, it's super simple, but I don't see that in any of our like prints for anything when I was going through it. So I don't know if they changed that. I would think that the rack controllers need upgraded too.
Well, see, this was when it first came out. I got these prints a while ago. So here you can see the print for the heat exchangers, right? So circuit 1 from rack, circuit 1 from rack, circuit 2 from rack, circuit 2 from rack.
Yeah, that's how ours is, except they want the liquids teed together at the pump skid.
Yeah, basically you're going to bring one line up and then separate and then going down in, right?
You have to bullhead it.
Yes.
Or else they're going to be very mad. Now, I will say this. They have go back down. So you got the air you got your expansion tank in there. Now they have a entire chart for setting this expansion tank. Before you go to start this, scan the QR code inside the unit, okay?
Mm-hmm. Mm-hmm.
And it's going to bring up, there's a expansion tank setting guide. Now, little weird, like how they're doing it. Like they're figuring out some of the math for you. Now, mine was on the ground. So my expansion tank setting was way higher. So they want to run a 10-pound static pressure all the time. So at the highest point, they want 10 pounds of pressure. So I was at like 25 feet was my rise. So I had to have 10 pounds of pressure there. So at the bottom of my pump skid, my pressure is going to be higher.
Is this the one you were speaking of? The chart like this?
Mine wasn't that nice. Mine was just like
No, maybe this isn't the one. Minimum 20. No, I think this is the pump curve.
Yeah. So like I ended up having to have a 28-pound expansion tank setting, which is pretty high.
Because you were having to pump the fluid up into the rafters and such.
So right? A 25-foot rise is roughly 10.5 psi. If you for the 25-foot rise. So you got an extra 10 pounds there. And then they want to have a minimum of 8 pounds all the time. So they want to run a minimum of 18 psi total. So they want an 8-pound minimum suction plus a 10 pounds at the top of the riser. So it's a minimum of 18 plus that 10 pounds, that 10.5 pounds of at of rise pressure. So you got to add that together. So it ends up being 28 pounds. So I had to set my expansion tank to 28 pounds with nothing in it.
This is funny though. So remember we were just looking at the sequence of operation. That was one of the first things we looked at, and it said 15 degrees to maintain 20, right?
Yep.
And this is saying designs are based on 27-degree entering fluid with 20-degree leaving fluid. But no, that's just that's
return to supply.
Yeah, that's just return to supply. But they say right here a 3-degree approach.
That wasn't a 3-degree approach that they had earlier.
That's what I'm noticing. I'm noticing that there's a conflict of what it's saying here. Give me, when you're ready, just give me the other link to that so I can rifle through. Because like I said, all the shit that I have is
I'll have them rescan the QR code because it's hard to find their website without the QR code. Mm-hmm. I will say this though, you have to get that expansion tank set, and they have 40 pounds of pressure in them, which is extremely high. So do not start this up with the expansion tank set at 40 pounds.
I agree with you.
Or else you're going to have a lot of problems. But yeah, that's been the trip with this. I would much rather be working on that though than doing these Danfoss conversions, and I want to blow my brains out because this has been an absolute shit show. I'm doing Danfoss 326s to 2 valve controllers. It's been
you like that so much, like having microthermal.
I do, but I absolutely despise Danfoss valves now. Like the high pressure valves are great. The ETSs and the CCMs or the CCMMTs,
yeah,
have been nothing but problems. Like I had another one back off the stem.
I was trying to figure out why the hell it would do it.
There's no C-clip on them. Like, why? It should sit there and spin, but it doesn't. It's I don't know if they get wore out or what, but like it backed off. So I pumped the rack down because I went to go start it up, and it wouldn't open. So I pumped the rack down, go to take the valve apart, and it's in pieces. So I screw the head back together. I zero it out before I shut it or put it back in there. I zero it out. I put it in there. It runs for a half an hour and unscrews again. And it's wired the exact same as the other 4 racks.
It was leak lock day, and they forgot the leak lock.
But I've had this happen twice now.
I know. I remember.
And it's not a wiring issue because this is exactly how I wired the other racks. And I looked at another one of this manufacturer's racks where we have 2 valve controllers, and it's exactly the same way. So with microthermal, you need to invert red and green. If you're using a Danfoss valve on a 2 valve controller, it's red and green. Get inverted. And they drive fine. But you cannot zero them by just doing initialization like in the beginning. You need to actually drive them shut by power cycling it. But again, this ETS walked off the stem. I don't understand why these Danfoss valves do that. I ended up getting so pissed off that I cut it out and put a CDS valve in.
Come on.
What?
Pressure's a little high for that, isn't it?
800 pounds. Oh,
for the BGV?
Yeah.
Oh, I thought you were talking about for the HV.
No, it's ETS valve. So.
Oh, okay.
You're like, not that.
I was like, you've said a lot of shit on here, and I'm like, what?
You're like, really? But no, I actually like a CDS 7 or a CDS 9, the Swiss Army knife of valves, works perfectly fine in that. But the ETS 100 and a CDS 7 are pretty much the same valve.
You said ETS, the ETS
valve?
ETS
100. So I crossed that over to a CDS 7, and to be honest, it's a lot smoother.
Damn. Electronically operated expansion valve. Maybe that's not the one. Oh, yeah, it is. ETS.
It is. That's it.
It is, yeah. Oh, I see which valve it is. It's okay.
Hate that thing. Push it down a freaking cliff.
Beautiful.
So the other thing I found, which kicked my ass the first day, is there's preset transducers in microthermal for Danfoss. Okay. The one for the receiver pressure was not reading properly because the scaling was off in it.
Why?
Because whatever got set up, it never got scaled properly.
Oh.
So with microthermal, you can make your own sensors like CPC linear.
Yeah.
So you go through and figure it all out what the pointing should be.
Gotcha.
Unfortunately, when I was doing these, the Danfoss transducer cables have 4 different colors. And it matters who the hell assembled it, what color goes where.
Oh, you're talking about where they actually screw on the top, because you can put them either way, right?
No, it gets more difficult than that. So that connector, you actually have to physically put together. So that screw-in one on the top, there's flag terminals in there. Okay, there's spades in there.
I know I have one somewhere.
You have to put those together. That actually comes apart. And whoever assembled that, because it comes in pieces, whoever assembled that at the OEM, if they swap the wire around, which happened to me today. So one of the wires, the signal wire, was brown. Every other rack, the signal wire was red.
Oh, shit.
So I fought this thing for an hour. I'm like, what the hell's going on? This is the 4th one I've done. Like, they've all been the same. Like, I had to sit there and I had to go take the connector apart.
You're talking about on the ETS valve itself.
On the transducers.
Oh, okay. Sorry.
Yeah, I'm sorry, the transducers.
Okay.
Like the square plugged Danfoss ones.
Oh, you're talking about where it actually goes on the thing, where you actually have to, once you remove the screw from the actual plug, you can loosen up the cable and pull that out a little.
Correct.
And usually you have, like, on the Beacon ones, you have one that's a little bit wider, which is always your ground, and then the 3 others.
Correct.
You're saying when they put it together, they were like, today seems like the yellow one's going to go here and the white one's going to go, oh, shit.
And then, of course, like, they got to be different than everybody else. So, like, black is power and red is signal and brown was negative, except for the last one I did. It was opposite.
So it's just random day.
It was just random day. And it was just like, oh, you got to be kidding me. Like, I was just done at that point.
So note to self, that's something to check.
Yeah.
When you guys are going through and actually doing a startup on these, making sure that those connections in there not only are right, but they're actually tight. Because I fought a high pressure switch for God knows how long, because I didn't know that this was probably 10 years ago, but I didn't realize that connector came open. I just thought everything was nice and snug in there. I didn't know there was a small little flathead that you had to be in there to tighten that shit up.
So we've had a lot of problems on the original hill racks where they would vibrate and like that randomly you would get a transducer error because one of those would come loose, even though the screw was tight, but like the spade would come loose and you get a transducer error on a 326 and you don't know where the alarm was, because unless they get there and the alarm is actually an alarm, then you're screwed, because there's no way it doesn't record the alarms, which is the big downside of the 326. I like that controller. It's robust. It works good. The only downside is you have no way of logging the history of it. If
they just took that and just made it BACnet or Modbus,
it's works, but like they won't release. From what I was told, they won't release the data table.
Lame.
So it's I don't know. Like at this point, like they're hard to get. So I think they should all just be changed out.
No, they're going that way. It was the pack controller, and now I think they're doing something different, right?
Dude, that pack controller, I've messed with it twice now. I don't know. I'm trying not to be negative, but like, why would you have to shut the damn thing down to make it change? This is so counter. How are you supposed to tune anything if you're constantly turning it off?
I was with. When I first started messing with one of those, I was with Praven from Danfoss, and I made a change, and the rack just shut down.
Yeah.
What did I do? I'm like,
I did it remotely. I was like looking at one on a cell mode, and I'm like, I'm going to change this set point. It just shut off, and I'm like, ugh.
You thought you did something, right?
Yeah.
And then it booted back up. No, it has to basically like.
But then some stuff you can't change. Like you can't change. You can't see inputs.
You can't. You have to basically disable it in order to see some of the stuff, I think, from my understanding.
You can't see. I was trying to find a compressor alarm. You can't see the inputs for the alarms. Like you have no idea what it is. Like I looked for an hour and a half. you can't see the actual input that is alarming. It just says compressor alarm. But you have no idea. They list a bunch of DIs out, but you don't know what DI is what. There's nothing is assigned because you could change it how you assign it. So
yes, you have to go to there to actually know what it actually is.
Extremely difficult to navigate. It's the 326 side of it, like the high pressure valve and stuff. It seems to work fairly functional. It seems to have the same algorithm, and again, like the way they word everything, it's very confusing.
Or is what part?
Like everything's like acronyms. So you have to get their sheet out. Like it's a PCA is like drop leg temp. Like PCO is pressure.
I just saw that document. I was cleaning shit up today. It doesn't look like it, but I was cleaning shit up today, and I have that document where it actually breaks down what SGC is and all that other shit. You know what I mean? I made a Word document where it was basically because I took that and read it, put it through ChatGPT. I was like, recreate this document. Just took a screenshot. I was like, and make it color coded. Make each writing what sensor, what color it is. You know what I mean?
I'm doing that with the valves. I'm done trying to figure all this shit out with all these OEMs. Like I'm literally making a sheet this is for Danfoss to Sporlan. This is for Danfoss to Microthermal. This is for Danfoss to iPro. This is for Sporlan to iPro. This is from. It's insane trying to find all this information of what these valves are supposed to be set to.
You and I need to work on that together because I have a really good idea for that, and I think it'll make it even better. Like I understand what you're doing, but I don't want to give it away, but I just have a really good way of doing it. What I was thinking about. So
let's do that.
All right, let's end on that, and let's see if we can actually get Ketotherm or Ray Corp on here because we got questions.
Maybe both of them together.
Oh my god, that'd be amazing.
Or a ring match.
Fight to the death
with Novar just refereeing.
All right, guys, we'll talk to you guys next time.